I'm going to attempt this month's TMiP Animation Generation Collaboration task, which is to make an animated proof of Pythagoras' theorem. And once again, I'm going to do this in LaTeX using TikZ. So I'm going to start by doing the usual LaTeX document stuff. I think it's paper size. Let's just have a look at last month for how you do paper size. Oh, just paper width and paper height. Okay, that's easier. Make the margin 0. Right, so we've got a document building. Let's do a no indent and then a TikZ picture. And we'll start by drawing a right angle triangle, and I'm going to do a 3, 4, 5 triangle, just because it will be simpler to work out where the coordinates will be in that. And let's do line width equals 1 point, line cap equals round, line join equals round. Looks nice already. So I'm going to start by drawing a right angle triangle and putting a square on each side. So do that by saying 0, 0, 4, 0, 4 minus 4, 0 minus 4. Cycle, we'll put a square at the bottom. We're going to need to make the paper taller to make this work. Paper height 8. Probably needs to be taller than that. Let's try 10. Then let's put a square on the left hand side over there. Minus 3, 0, cycle, and a square on that diagonal. So 4, 0 to 0, 3. So that went 4 across and 3 up. So to go 90 degrees to that, we need to go 3 across and 4 up. So it's going to be minus 3, 7. Let's see if that looks like a right angle. No, so it's going to be plus 3 and 7 because it goes through the other way. That looks about right, but the paper's going to need to get bigger again. Then we go to 7, 4 and then cycle. Right, now the paper needs to fixed size. trial and error, I'm just going to work out how big the paper needs to be, but I can just do it by looking, because I know that in Y it goes from -4 to 7, so 11.2 should be enough to also have some lines. And in X it goes from -3 to 4, no, to 7. So 10.2 should be enough with some lines added. Right, okay, so we've got a right angle triangle. I now want to... How are we going to do that? I'm going to start by colouring in the two... these two squares. So let's do that by doing fill red, that one, and that one. There we go. Oh, let's put that under the lines. And the red is maybe a bit bright. Let's do it in orange, because latex orange is a nicer colour than red. Yeah, that's nicer. So the way I'm going to prove this is I'm going to, in fact, let's make them two different colours. Let's go for orange and cyan, because I think they're a nice colour combination. There we go. So what I'm going to do is I'm going to make both of those slide to be parallelograms, and then slide upwards to fill the other square. So for the first bit of the animation, I'm going to make them slide into parallelograms. So let's call this anim A1. And we'll make it go from, well, let's say 0 to 100. So if I do A150, let's see how that goes. Right, so if I make this a new command, like that. Oh, I did this recursively last time, didn't I? I can look at how I did that recursively in a bit. So if we assume that the input goes from 1 to 100 and is how far across these have slid. So I want to go from there and go to... So it's going to slide over to meet up with that one. Let's do this in red just so I can see where I'm going to. These two vertices are the two that have to move, and they're going to go to... We've got to slide across by 3, so that would be -3 and 1. Let's build that. Okay, so that is the parallelogram we're aiming for there. And for the other parallelogram, we're aiming for these to slide down by 4. So that would go to there. Put that in red. Okay, so those are the two parallels we can go to, and then we're going to slide that upwards and turn that into the other square. So if for the first one, we want these numbers to be take away 3 times #1 over 100 if there's 100 frames. And that wants to be -3 times #1 over 100. And I can delete that. So that looks like that's about halfway between, so that's good for this animation. No, it's not. I'm not going to do that. I was going to do a command for the number of frames, but if I just find and replace 100 with something else, that will be fine. and this one here, so this is going to be -4 times #1/100. And this is be this -4 times #1/100. Okay, so that should make the first one of those. I'm now going to look at what I did last month for the recursive thing. There we go. I did new counter animation like that. So let's copy that. In fact, rather than just dividing by 100, let's just make it take an input between 0 and 1. And then this function can deal with how many frames there are, and that's much simpler. Right, so that was to do 19 frames. Okay, so here I want to do A1 of... Let's just close that, I don't open anymore. The animation divided by 20. That's not what I wanted. Oh, because I've not included the new command. Okay, I need the if-then package. Okay, so now that should go like that. They slide into parallelograms, but they don't ever hit the final one. Let's see, if I make this 20, do I want the final frame there? Yeah, if I leave the final frame off, the next animation can start with the first frame. That makes sense. Right, so that's the first bit. Now we need to make the whole thing slide from there 5 units up diagonally. So let's copy this and this. Make an A2. Make an A2 here. Animation 2 there. And put 2s into all of these. So that should now make the animation that goes once and then does the same thing again. Yep, so that I've just made a copy of the same animation. I now need to make the second one move diagonally. So I want to start from where this one ended, which is where this is 1, this is -1, this is -4, and this is -3. Let's just check that's where that ended. And I want to go to this, but shifted upwards. And how it should be shifted upwards by, that's given in one of these here. 3 that way and 4 that way, because this went from 3 to 7. So we're adding 3, 4 to all of these. Oh, so there's a much easier way of doing this then. Begin scope. Shift equals 3, 4. So it's the shift from there to there, and if I just do shift this times #1, this times #1, that will do that. So now we have an animation where we go to the parallelograms, slide upwards. Why was there a jump? Ah, because I've put a Do I have a new line in there? Is that the problem? Better to take the new lines off after end TikZ picture. There we go. Okay, so how does that look? We go there and we slide upwards. And now for the final step of the animation, I then need to make those parallelograms slide up to rectangles so that they fill that square. So let's make another copy of this animation. Let's do an animation 3. Copy all of that code. A3. Just find and replace 2 with 3 for the rest of the file. And this is going to start. So let's just leave the Shift 3-4 on. So this is going to start there. So now it should. There we go. It slides up and then it just stops. And that's the one we want to play with. And then we want to do the shifting of these. So let's just in red to work out where we're aiming for. We want to shift the right, so in the orange one, the 0, 0 point wants to move up to the diagonal, which, is that even going to have integer coordinates? I don't know. There's a way to work it out. So that, okay, the bit of the orange one that's included inside the triangle, inside my original right angle triangle, is similar to the full size triangle, so I can do this with some scaling down, with some similar triangles. So in the I can work out those lengths. Oh no, much easier. I can work out the equation of the line between the two parallelograms, the equation of the line, the equation of the black line, and work out where those two meet, because the parallelogram goes from right, okay, so this is now at 0, 0. It's going to be easier if I actually add 3 and 4 to all of these. Or is it? Yeah, okay. So this point becomes 0, 0, and this point becomes 3, 4. So we've got 0, 0, 2, 3, 4. That's the line which we're doing. So the equation of that line is y equals x over 4, 4x over 3. And then the other line we've got goes from 4, 0 to 0, 3. And that's going to be y is equal to gradient x plus c, which is 3. And the gradient here is minus 3 over 4. There, okay, so where do these two lines meet? Well, that'll be when that equals that, which is when that plus that is equal to 3. So put these over 12, so that's going to be 9 over 12, that's going to be 16 over 12, 16 plus 9 is 25 over 12. It's 36. X is 36 over 25. Okay, and that would mean y is equal to 36 times 4 over 25 times 3. That cancels with that to make 12, 2048. Okay, so that means that what we're aiming for is when this is 36 over 25 and this is 48 over 25 and this one is plus this plus that. Right, let's see, does that look like the rectangle we're aiming for? That looks exactly the rectangle we're aiming for. And then for the cyan one, we add the same values in. 48 over 25, I think it's, yeah, it's the same point there. That's what we're aiming for. Okay, so now we can do this as, so these would be these times #1 plus this times #1 plus this times #1, and cyan will look the same, be that, except this needs to change to back to 0, 3. This is -3, 1. Copy the line below. Those points are the same. Get rid of that. And now, or nearly, okay, I've typed a point wrong. Um, 0, 3, -3, -1, right. Right, I'm back. Let's finish this. So we have it going to there, and then weirdly jumping, and then looking okay. So why is the first frame of this last animation not in the right place? Is my first question. So if #1 is 0, (36 over 25). This should be, oh no, it's this one over here. Oh, I don't need some brackets in this. Let's just check by filling it red without the #1. So if #1 is 0, oops. Okay, I've done something very wrong there. Let's just do zeros then. Oh, I see what I did wrong. Right, so it goes in there too. Okay, if I just replace that, right, so if I do a hash, right, let's put that on top. Okay, it's starting off at 1 over 20. Why is it starting off at 1? It should start off at 0, shouldn't it? What? So how come it's starting off at 1? Animation 3, can I do that? I can. Put the number, so it's starting off at 1. If I print it right at the beginning there. Got to be a quicker way of doing this. So it starts off at 0. But then for some reason it's 1 as soon as I get into this function. It's one of these other ones changing my animation 3. That's working now. Oh, is it going off the page? Do I need to put those new lines back in? Right, let's see how that looks. So we go there, go to there, we go up here. That works now. So it must have been putting the next frame to the right off the side of the page. That's ridiculous. But we fixed it, so let's get rid of the red. And now we have an animation that goes from the starting squares to the parallelograms, push the parallelograms up, and then up to rectangles to show that those two have the same area. And because you can slide the top and bottom of a square into parallelogram without changing the area, as long as you don't change the height, this shows that Pythagoras' theorem is true for this triangle, and you could make it show it's true for any other triangle by changing the shape of the original right angle triangle that we started with. So what I want to do now for the animation is make it go back to where we started. So let's make animation 3 reverse. Three replace with 4. Right, but that wants to be 3. 1 minus there. Animation 4. So then we've made a copy of that, so it goes there, then it reverses. Oh, that's not staying. Or is it? Is that staying parallel? Oh no, it's the right. Okay, it's the reverse one is weirdly not staying parallel. Probably need some brackets on that or something. Yeah, thought so. Oh God, this is horrible. So I might need to copy the whole animation just so I can do 1 minus, or can I use the calc package to do the 1 minus for me? Or can I put curly brackets around that and it'll fix it? Oh. I'm gonna have to make copies of all these animations and do it the long-winded way. That's fine. So let's make a copy of A3. Change all the 3s to 4s. Then I want to place this with 1 minus this. So it's going to be that minus, that minus, that minus, that minus, and then we want similarly, we want to be that minus, that minus, that minus, that minus. Let's see what that looks like. So it gets to the end and goes back. Yep, and then we need to do 2 backwards. Let's make a copy of this 2. And let's call this 5. In, and for this one we want to replace 1 with -1. Oh, okay, so this one I probably can just put no, it's gonna be 1 minus. Okay, it's gonna be too, it's not gonna like that, so let's just put it in like that. Let's see what that looks like. So we go down, down, yep, and then we just need to do number 1 backwards. So let's put in a animation 6 at the bottom. Replace 1 with 6. 6. Oh, okay. Alright, and replace animation with animation 6. That one, that one, that one, that one, and that one, and that one will replace. And replace that with 1 minus that, and now we should have a looping animation. So if we go back to the start, we start off with 2 squares, they slide over to parallelograms, slide up to fill that square, slide back and slide back. And now that is going to feel like a very, very speedy animation that jumps over the important bits a lot, because we want to put in some frames of, we want to kind of stop at the completed square at the end and then stop again at the 2 separate squares at the end. So this is going to be A3. So after animation 3, we'll put some A320s in. Let's do 10 of them and see how that looks. They're all blank. That's not what I expected. Oh, because I've done 20. It's not 20, it's 1. We framed 20, but there was a divide by 20 inside the animation function, so it should be passing a 1 in there because it's at the end of the animation. And we need some new lines between these because I can see it's trying to put it off to the right hand side. There's a small black mark over here. There we go, it stops there for a bit. And then let's put the same number of these at the end, but instead of being A3 ones, they should be A1 zeros, because they're the starting frame of the first bit of animation. Let's check that looks okay. Yep, so we get to the end and then we stay on the final one a little bit. Right, so that is my animation. And now I'm going to look at the convert to MP4 script. Hopefully will just work. Did I call it frames.pdf? I call it frames.pdf. So if we're lucky, we'll run this convert to MP4 script and this will spit out a video file. So it takes its time because it's doing, we can watch it making these frames. There are 140 frames in this video, and it's up to 70. And now it's going to make the video. Oh, that's a very jumpy video. Why is the video so jumpy? Frames aren't that jumpy, are they? No. The frames seem to go much smoother than the video. Is it just that my computer's running really slowly because I'm running OBS at the moment? It might well be actually. If I make the video smaller, it seems to run quicker. Yeah, I think it's just my computer's running very slowly at the moment for some reason. All this video file is huge. It's not actually that big. Well, I'll turn OBS off and I'll see if it looks better when I'm not running lots more software on my computer, but I think that should be my finished animation unless I appear back here shortly and have another go when I work out what's wrong. So as usual, I will put the code I wrote to make this on GitHub. I'll put a link in the description below, and I'll also put a link to the finished animation and to the animation generation page. Thanks for watching. See you next time.